All right, this is PreAP, PreCalculus, note section 3.2. We're looking at examples 3 and 4. 3 is similar to the first two. I've already got the work written out for you. It's already written out in your notes as well. Just want to show you a difference between this problem and some of the other ones. So we factor this little fella. Set each factor equal to 0. These are our X-intercepts. Even though a 2 happens twice, we only put this on our number line once. We found that this ends up being negative, and then positive, and then negative and negative. We're asked to find when this is less than or equal to 0. That means h of x is less than or equal to 0, which means it's non-positive. That includes when it's equal to 0, when it's negative. And here's the part that I want to focus on here. Explain how your sign analysis and the process above is confirmed by the graph. So what some students assume is that whatever you start with, negative or positive, is always alternates. We can see here it goes from negative to negative. How is that possible? Well, that's possible because it is tangent to the x-axis here. It doesn't actually cross through it. So answering this question, when h of x is positive on the interval from -2 to 0, the graph of h of x is above the x-axis. This is a great question to ask on a test, this type of question. When h of x is negative on the interval from -infinity to -2, 0 to 2, and 2 to infinity, the graph of h of x is below the x-axis. So that is confirmed in this positive and negativeness. How would your solution to the above inequality be different had the original inequality been like this, as opposed to less than or equal to, it's greater than or equal to? Well, if this was what we were given, it means non-negative. And this occurs on the interval from -2 to 0. And then it also occurs again at 2, because it's equal to 0 there at 2, but it's not above it. So this is a different way that we could have written the answer that hasn't appeared before in the first two examples. All right, so the point of this second part of the notes is really to show you what to do using a calculator. So let's examine this, because some problems you just can't factor. Consider the polynomial inequality, this little fella here. First of all, what do you notice about this polynomial as opposed to the previous examples? What you might notice is this does not have 0 by itself. So let's write that down. So what do we notice? The polynomial is not compared to 0. As it should be. It should be compared to 0. So what we're saying, it's not as it should be. It should be compared to 0. Another thing that's different about this, if we get it to compare it to 0, this not being compared to 0, and this next point, these are not related. They just happen to both happen in this problem. This doesn't appear to be factorable. If it's not factorable, then how are you going to find the x-intercepts? Well, let me show you how to do this. At this point in time, not all polynomials are completely factorable. Therefore, in order to solve it, we are going to use our graphing calculator. So let me see if this works the way I hope it's going to work. Here's my graphing calculator. Turn this little fella on, and it is not being responsive. Come on, little fella. There we go. Now, if I go to y equals, I've already typed this function in. I've typed in x cubed minus 9x minus 3. I would expect you to do the same. If I hit graph, I would like to be able to see all the highs and lows of this curve, and I can't see the lowest point. So I'm going to go to my window. X min and X max, left and right looks okay. My Y min, I'm going to change this maybe to like a -20 so I can see this better. There we go. That's a better picture. Now I want to figure out what the x-intercepts are. And here's how you do that. We're going to hit second calculate. I didn't hit calculate. Hit second calculate. That's above the trace. We're looking for a 0. So I choose that and I hit enter. Now right now, a couple things that this shows. It says left bound question mark, and at the top it shows the function. I need to move, by using the left arrow, this cursor to the left of my x-intercept. It's on the right, it's on the right. Now it's on the left of the first one. Doesn't matter how far to the left you are. I hit enter. Now it says, well, move me to the right. What's the right bound? So I hit the arrow to the right until my cursor gets clearly to the right of the x-intercept, and I hit enter. Now it says, would you like me to guess the x-intercept? I would. I hit enter, and it says negative 2.8169. We're going to round to 3 decimal places. I'm going to make it negative 2.817. I'm going to write that down in a little bit. For the time being, just bear with me here. On the right, it says that y is 1 times e to the negative 12. That means 0.0, 11 zeros, and then a 1, which means super close to 0. Keep in mind, it said it was going to guess the x-intercept. So this is a rounded number, including the y value, which should be 0. 0.11 zeros and then a 1 is super close to 0. To find the next x-intercept, I hit second calculate again. I choose 0. It says left bound. Move my cursor somewhat close to the left side of the next x-intercept. I hit enter. Then I move it to the right side of the x-intercept, somewhat close to it. I hit enter. Then it says, you want me to guess? I would like you to guess. This one is negative 0.338 through 3 decimal places. Notice it got the y value spot on this time, which is 0. Hit second, calculate again to find the third x-intercept. Move my cursor relatively close to the left side of the x-intercept. That's probably good enough. I hit enter. Then I move it to the right side. Keep hitting the right arrow to get over there. Hit enter. It's going to guess. And it gave me 3.155. So if I come back here, I'm going to graph this on here. Just wanted to show you how to use your calculator. This graph, we said, crossed right around here, and then right around here, and right around here. I got these written down on my paper. So I'm just going to draw this curve. It came up, came back down, came back up. So this first x-intercept was negative 2.817. And the next one was negative 0.338. And this third one was 3.155. This is supposed to be 338, not 388. 3.155. So let's read the directions, make sure I actually followed the directions. Arrange the inequality so that all the monomial terms are on one side, did that. Compared to 0, did that. Graph the function on your calculator, did that. Draw what you see on the grid, did that. Enter y1 and use the 0 function to find the 3 zeros, did that. Those 3 zeros, once again, are x equals negative 2.817, negative 0.338, and positive 3.155. To be clear, in this class, we always round to 3 decimal places. Graphically, what does the solution of this represent? What would those intervals be? So let's answer the first part. The solution to x cubed minus 9x minus 3 greater than or equal to 0 represents where the graph is on or above the x-axis. You could also say it represents where the graph is non-negative. So I'm going to make my sign diagram for this. And I'm going to put my x-intercepts since I didn't factor this, I could still write this in factored form. If I know these are the x-intercepts, in factored form, this would look something like x plus 2.817, x plus 0.338, and x minus 3.155. So if I pick test points in here, like a -10 and a -1 and a 0 and a 10, and I plug this into this, here's what we would find. And I'm going to go through all the details because I don't want to take up more of your time. This ends up being negative, this interval is positive, this interval is negative, and this interval is positive. So since we're looking for non-negative, we're looking for this solution where it's positive and the endpoints, and this solution where it's positive and the endpoint. So that means inclusive, negative 2.817 to negative 0.338 to 3.155 to infinity. Well, that concludes it. Hopefully you understood how to use your calculator. If you need more help with your calculator, please let me know. Please finish the homework from this section.